All right, guys, today we're going to take complex numbers into powers of them and take roots of them. Yesterday we multiplied and divided them and turned them to trig form. Now we're going to raise them to powers and take roots. All right, De Morgan's theorem, I said that real quick. For any complex number, the way you find, this is basically how you raise a complex number to a power, is this. If you have a complex number, you're going to raise it to a power. If it's in trig form, you raise r to the power, and you multiply theta by whatever power it is. Let me just show you one here. All right, the first one says 1 plus I to the 9th power. I went ahead and found my r, because we did that yesterday, found theta, 45. So I'm going to write it in trig form, which should be square root of 2 times cosine 45 degrees plus I sine 45 degrees. And I'm going to raise it to the 9th power. So if I raise that whole thing to the 9th power, this is the steps you take. You take the square root of 2, you raise it to the 9th power. You take the angle inside, the 45, and you multiply it times 9. Everybody knows 9 times 45 is 405 degrees, plus I sine 405 degrees. All right, and that's how you set it up. Now, square root of 2 to the 9th power, and I'll show you why this is true tomorrow if you really want to see it, but it's 16 on 2. That's what you get when you raise square root of 2 to the 9th power. Cosine 405, actually if you do that, that's 45 away from 360, so it's really a 45 degree angle in quadrant 1, which means it's really 45 degrees. So cosine of 45 degrees is square root of 2 over 2, and so is sine. So I'm going to substitute the square root of 2 over 2 where the 405 was, and then I'm going to multiply. When I multiply the 2's and the 16 cancel, so it gives me 16, and square root of 2, square root of 2, gosh, that's a lot of stuff I just said. Here's what's happening. 2 goes into 16 8 times, so I have 8 times square root of 2 times square root of 2, which is really 2, so that's 16. Same thing happens on here. 2 and 16 cancel, goes into 8, so I'm going to get 8 times square root of 2 times square root of 2, which is 16i, and there it is. There you have it. Not too bad. I got another one here, so let's just see 2. So square root of 3 minus I to the 10th power. I went ahead again, found my r, found my theta. So let's go through real quick. If I write it in trig form, it's going to be 2 times cosine 330 degrees, I sine 330 degrees. And I'm raising all that to the 10th power, which is huge. So I have 2 to the 10th out here. Inside, I'm going to do 330 times 10, which is 3,300 degrees. I sine 3,300 degrees. Now, one of the hardest things I have to do, it's not really hard, but one thing I do have to do is I have to figure out where 3,300 degrees is. Now, if you go around a circle, you keep going 360, 360, 360, you end up finding out, first of all, that's 1,024, that 3,300 is 60 away from the x-axis in quadrant 1. So that means it's really 60. That's really a 60 degree angle, 3,300 is. So these are ones that we know. Cosine 60 is a half. Sorry, that should have been I sine right there. I don't know what I'm doing. Sine 60 is square root of 3 over 2. So just multiply that out. Half of 1,024 is 512. Same thing here, 512i on 3. And that's all you got to do. That's not too bad. All right, now if you're going to take roots, instead of raising them to a power, if you're going to take roots of complex numbers, here's the formula for that. Here's how we're going to roll doing those. First of all, we're going to put it in trig form. We're going to take the r out here. We're actually going to, it says 1 over n power. That means the root. We're going to take the root. We're going to take theta divided by n plus k times 360 divided by n. So that's going to be pretty big on the top. Or k is 0, 1, 2. N minus 1. We're going to keep putting k's in until we get to 1 less than what the root is. That probably makes no sense whatsoever. Sorry, I can't get my throat clear. Let me show you the next 2 slides. I got 2 examples of these, and I think they'll really help make more sense than just reading what that formula has. But it's good to have it down to look at before you see this next 2. All right, stay with me on this one. Went ahead and found, not sure what happened right there. Went ahead and found my r and my theta like I did a minute ago. So the trig form would be 4 times cosine 60 plus I sine 60. And because I'm finding a square root, my k, I'm going to use 0 and 1. You remember you always go one less number than your root. You'll do the number of numbers of your root, but they'll end up one less. So here we go. I'm going to take the square root of the number in the front. Inside, I'm going cosine of 60 degrees divided by 2 plus 0 times 360. That's at 60 over 2. Do the same thing with the sine. I sine 60 over 2. 0 times 360 over 2. So that should just be, I messed up there. That should not be a square root of 2. It should just be a 2 outside. Sorry about that. So that basically gives me this. 2 times cosine 30 plus I sine 30. And those are numbers that we know. Cosine 30 is square root of 3 over 2. Sine 30 is a half. So that means one of the square roots is square root of 3 plus I. That's one of them. Now to find the second one, I'm going to do the exact same thing, except now my k is 1. So I'm going to say square root of 4 is 2 times cosine 60 over 2 plus 1 times 360 over 2. That's a 360. Plus I sine, same thing, 60 over 2 plus 1 times 360 over 2. So if you work that out inside, you get 420 over 2. 420 over 2 is really 210. So I got cosine 210. I sine 210. 210 is really a 30-degree angle in quadrant 3, which means this is negative square root of 3 over 2. This is still, well, that's negative 1/2. So my second square root would be negative square root of 3 minus I. That's all there is to it. It looks worse than it is. And once you do a couple of them, it'll start speeding up. Let me show you one more. All right, last one here. Find the cube roots of 1. And because they're cube roots, there's going to be 3 cube roots of 1. What I went ahead and did, well, I actually worked it all out, but went ahead and worked out the trig form of the number right here. Same way we always do. That's your r. That's your 0 degrees was your theta. So, and don't forget, k is going to be 0, 1, and 2. To get all 3 roots, k should end up 1 less than what your root is. So you start at 0, go up 0, 3 of them, 0, 1, 2. So if you just plug 0 in where your k usually goes, you're still stuck at 0. Your first one's always going to be the original. So I take the cube root of 1, which is 1. Cosine 0 is 1. Sine 0 is 0. So just distribute. 1 times 1 is 1. 1 is the cube root of 1. We already knew that one anyway. Second one, cube root of 1 times cosine of 0 degrees plus 360. 1 times 360 is 360. Both of them are over 3. Same thing with sine. Basically, it's 360 divided by 3, which is 120. 120 is one you should know. It's really 2 power 3, or 60 degrees in quadrant 2. Cosine is negative 1/2. Sine is square root of 3 over 2. 1 times anything is itself, so there's the second cube root of 1. The third cube root, did in green down here. Cube root of 1 again is 1. And I did 0 over 3 plus 2 times 360, which is 720 over 3. Same thing here with the sine. That's really just 0. So 720 divided by 3 is 240. So both of those are going to be the same. Both 240. 240 is 60 away from 180. We're in quadrant 3, which means cosine is negative 1/2. Sine is negative square root of 3 over 2. 1 times anything is itself. So I just brought itself over here. Negative 1/2 minus square root of 3 over 2. I. And that's it. So we'll do some of these, of course, tomorrow. Hopefully they won't be too bad. Shouldn't be. And I'll see you then. See you. Bye.